Hey there, y'all. It's your math teacher, Mr. Boyd, and I'm back at it again today. And today we're going to take those quadrilaterals we've been working on, and we're going to start putting them in the coordinate plane, meaning we're going to start graphing them. Okay, before we can do that today, we first need to review a couple of concepts, either from middle school or from Algebra 1. Make sure we have those. Otherwise, what we're about to do is not going to make a whole lot of sense. So let's begin. First thing we need to talk about is slope. Okay, and so just as concepts go, we need to make sure we know what these different kinds of slopes look like. So we know a slope says how steep something is. Do you remember what a positive slope looks like? Right now, why don't you put your hand in a motion that would show what a positive slope looks like? Something that goes up and to the right is what we're looking for. If that's a positive slope, what's a negative slope? Something that goes down as we're going to the right. A zero slope, like walking on a zero slope, that should be pretty comfortable. That's flat ground. And an infinite slope. Now, if you remember rise over run, all rise, no run, okay? Straight up and down vertical. Zero slope is horizontal, okay? So that's kind of like our little precursor. Now let's get into how we find slopes, okay? So normally, you're going to need some points to be able to do that. You'd find the slope of the segment that connects 2 points. Now what I've got right here in the middle, that should be familiar to you either from Algebra 1 or from middle school, or if you took Algebra 1 in middle school, there too. That's our slope formula. Now a lot of teachers say it's rise over run. Guys, it totally works, okay? That's the y values. There's our y values, divided by our change in our x values. Okay, so there it is. Now, if you struggle with formulas, don't get overwhelmed with the fact that that says y2 and y1. It just means one of the y values, another one of the y values, an x value, another one of the x values. What will make this a lot easier for you is if you come right down here and label that as x, y, x, y. Now, we have to decide which one is x2 and x1. You want to call this the first value or the second? A comes before B in the alphabet. I'm going to call this x1. We could have called it x2, that would be fine. The only thing you have to realize is if this is x1, this is y1. They have the same what's known as an index number, okay? And then over here, if that one's a 2, that one is also a 2. So y'all, here's our first example. It's as easy as this. All we're going to do is we're going to plug in the numbers and simplify them. So I'm looking for my y2 number. y2, we just labeled that as 1. It says to write a minus. Okay, I can do that. y1, we've labeled that as 6. Fraction bar, and there's a minus down here. We've labeled our x2 value as being 5, minus, and then x1 is negative 3. Now notice, this negative came from right there, and this one came from there. We have to write both. And so now we can simplify. 1 minus 6, that's negative 5. What about 5 minus negative 3? So minus a negative is like a plus, and so that's negative 5/8. Okay, and that's the slope. Now, if you're a visual learner, we could always graph this and see if we get the same thing. So I'm going to take a moment and graph these points. Negative 3, 6. There's point A. We'll come down to point B, 5 to the right, up 1. And I'm going to connect those. And the easiest way to do this is to make what we call or a lot of teachers call, a slope triangle. Okay, and so what we do now is we figure out to get from A to B, what do we have to do? We have to count down 1, 2, 3, 4, 5. Negative 5. We have to count to the right. 1, 2, 3, 4, 5, 6, 7, 8. Now, that's the rise, because up and down, that's the run. Negative 5 over 8. That's the exact same answer we had up here. So I hope you see the connection. The formula produces the same understanding as if we understand rise over run. Okay. The only thing I'd like to add to that is some of us really rely on the visual method, and that could get us in a little bit of trouble if these numbers, the numbers that are our coordinates, are really, really big numbers, or if they're decimals, or if they're kind of funky fractions, we may get into a little bit of trouble. So it's really important that we understand how to use a slope formula appropriately to find those. Okay. Now on to midpoint. So we've got the midpoint formula here, and right here I've got those same points. The one thing that I'd like to add about midpoint is the midpoint is just an average. And here's what I mean by that. If I give you 3 numbers, 3, 5, and 9, how would you find the average of those 3 numbers? Like literally just going back to like 4th or 5th grade, how would you find the average of 3 numbers? I hope you know that you would add them all up and you divide by how many numbers there are. In this case, there's 3. Okay, and that looks like that's probably 17 over 3, which ends up being some sort of a decimal. Okay, it's not a whole number, so I'm going to leave it as is. That's the basic concept. And what I'd want you to see down here, it's the same thing. We're going to take our x values, we're going to add them together. Because there's 2 of them, we're going to divide by 2. Same thing with the y's. There's 2 y values, we add them together, we divide by 2. We're just finding the average of the x's. the average of the y's. Now, when I learned this back in, like, I don't know, 8th or 9th grade, I got really confused because I'd forget, wait, is it the x's on the left or the x's on the right or whatever? Remember, when we write down a point, it always goes x, comma, y. And midpoints are points, so the x's are always going to go on the left and the y's on the right. Let's try this example. Okay, for this one, I'm again going to label this as x1, y1, x2, y2. If you get confused, you need to label those, okay? So what we get then is negative 3 plus 5, those are our x values, got to divide it by 2, comma, don't forget your parentheses, comma, our y values, 6 plus 1 over 2. And then what do we get? Looks like we get 2 over 2 and 7 over 2. Let's simplify those as much as we can. And we get 1 comma 7 halves. Now, if you want to write that as 3.5, totally fine with me. The one thing that's really important that a lot of students miss is that it is a point. And so your answer needs to look like a point, x comma y with parentheses. Okay, so there is our answer. Now let's go back and check our visual and see if this makes sense. 1 to the right, 3.5 up. Let's see. 1 to the right, 1, 2, 3.5 up. Okay, and it looks like I missed on my initial segment that I put in there. So if I hadn't curved this upward, looks like it would hit. Okay, and that point is right smack dab in the middle of A and B. Okay, third thing we need to get before we get into our full lesson is we need to make sure we remember how to find distances. Now, folks, there's 2 ways to do this. Okay, one of them is the Pythagorean Theorem. Okay, and that actually is the one that I like. The other thing I want you to notice is this little guy right here and that little guy right there. Those are the exact same things that we saw in the slope formula. y2 minus y1, x2 minus x1. And notice, in our visual, those are side lengths of a right triangle. So if I want the distance, and I'm doing a squared plus b squared equals c squared, the Pythagorean theorem, all I need to do is negative 5 squared plus 8 squared equals, I'm going to call it c squared if you want, and then I get 25 plus 64 equals c squared. We're going to need to add those together. So 25 plus 64, what is that? That's 89. And square root of 89. Okay, and if you want to make a decimal, you can. Decimal of that, I'll write that on the side, it's about 9.4. Okay, and so there we go. Now that's not the formula way, that's the Pythagorean theorem and visual way to do it. Anytime I can, I like this way. It's relatively simple, I'm good at it, and we can get really good at this way as well, and we're going to practice that right now. For some people, it's a little more challenging. What I hope you can see by the end of this example is that both methods actually do the exact same thing. Oops, y1, sorry, I made a mistake there, and then x2 and y2, and let's fill in our distance. So first things first, there's going to be a square root, parentheses, my x values, 5 minus negative 3, and that calculation should look a little familiar. We did that for slope, remember. And then we're going to take our y values, so 1 minus 6 squared. And now we're just going to simplify. We're going to do whatever we know how to do here. 5 minus negative 3, that gives me 8, so now I have 8 squared, plus 1 minus 6, that's negative 5 squared. And so I hope now you can see how that ends up in the same calculation as we had with the Pythagorean theorem just a minute ago. Okay, so now square root of 64 plus 25, and that is square root of 89. Okay, so the formula works just as well. The only challenge is sometimes it's hard to remember the formula. And so if we have a basic understanding that the formula comes from the Pythagorean theorem, then a lot of times that can bail us out if our memory should slip us on a test. Okay, so now with that said, let's do an example or two, and let's get really, really good at these. What I'd like you to do, go ahead and pause your video, try this on your own, then hit play and see how you did. Okay, I'm just going to show my work real quick here and show you how I did it. So for slope, all I'm going to do on this one, take my y values, negative 2 minus negative 2, and 6 minus negative 2, and I get 0 over 8, which is 0. For my midpoint, I get negative 2 plus 6 over 2, and negative 2 plus negative 2 over 2. What that comes out to be, 4 over 2, and it looks like for my y values I have negative 4 over 2. So I'm going to need to simplify those. And I get 2 comma negative 2. Okay, so there's my midpoint. And then for my distance, what I'm going to get, and let's see, do I want to do x values or y values first? Formula said x values. That's a plus, so technically you could do y's first if you wanted. I'm going to stick to the formula, though, for right now, just so it's easier for you to track. So 6 minus negative 2, square that, plus negative 2 minus negative 2, squared. Take the square root of all that, and it looks to me like we get 8 squared right there, plus 0 squared, and that's going to be 64 with a square root on it, which is 8. Okay, so we've got slope, we've got our midpoint, and we've got our distance. Okay, one more example, and then we'll get into the quadrilaterals. Okay, so this is a really good one to try. This one, totally a word problem, okay? So I want you to try it, and then we'll see how you did. Okay, the airplane takes off and climbs to an altitude of half a mile. At that same time, plane was 2 horizontal miles from the end of the runway. What's the exact distance the plane is from the end of the runway? What slope did the plane travel at? And what was the midpoint of its path? All right, so pause the video, try to draw a picture, and try to do this for yourself. Okay, every story problem is going to need the ground in it, typically. Okay, so I'm going to put my airplane up here. I'm going to say that it is 1/2 a mile above the ground. That's the altitude. 2 horizontal miles away from the end of the runway. So there's my triangle. Okay, and now we need slope, midpoint, and distance. So perhaps it makes sense to assign coordinates to this. If this is 0, 0, then this is -2, 0.5. Now folks, if you're playing along at home, it would have been just as valid to call that a +2 if you had flipped this triangle. That doesn't make it wrong. In fact, you might even argue it's better because then you don't have to deal with a negative number, okay? So that's totally, totally fine. Okay, now let's find our slope. Now guys, I'm going to do it the easy way. I'm going to do rise over run. We rose 0.5. Our run was 2. And so that comes out to be 0.25. That's my slope. Okay, my midpoint, I'm going to take my x values, 0 and -2. So 0 minus 2 over 2, comma, 0 plus 0.5 over 2. And when I simplify that out, I get -1 and 1/2. Or excuse me, 1/4 or 0.25. Either one is good. Okay. And what about distance? For distance, since I have a triangle here, I'm going to use the Pythagorean Theorem. So 2 squared plus 0.5 squared equals c squared. So I get 4 plus 0.25 equals c squared. Square root that. And I'm going to type in square root of 4.25 because we're going to approximate this since it's a story problem. And that comes out to be 2.06 miles. Okay, and that's all done. That's how it goes. Now that we have the basics down, we can start to try to apply that to real context and some more challenging problems. So that's exactly what we're going to look at here. Okay, and so we got our students over here, and our students are making geometric designs on a t-shirt because they look pretty darn cool. Okay, so it looks like the one that we're going to be looking at is the one that this gentleman here has on his t-shirt, and he's got some sort of a quadrilateral, and inside of that quadrilateral, and I'm talking this quadrilateral out here in blue, they found the midpoints, connected the midpoints, and you know what's interesting? That didn't look like any special kind of quadrilateral, but the one inside that's purple, the one that goes T, U, V, W, that one looks like maybe that's a square, rectangle, parallelogram, something like that. Okay, so that's what we're going to be after. We're going to try to figure out what that is. So to start, we're going to find the coordinates of T, U, V, and W. And the first thing we need to notice is that T, U, V, and W are the midpoints of the larger shape. So that connects to exactly what we just learned. Okay, we're going to be finding midpoints right now. So let's go through and let's find those. Let's start with T. Now, folks, my suggestion with this is pretty new doing this in terms of general coordinates. What I mean by that is we have letters, not just numbers now. So for probably at least the first 2 of these, you probably want to try with me. After you get your notes down for the first 2 and you're feeling really good, if you wanted to accelerate and try finding the last 2 without me and then check and see how you did, that would be a cool thing to try, but only if you're feeling like you're ready for it, okay? So to find point T, it's a midpoint. What I'm going to look at, point T is right here. It's in the middle of this segment. And so what I'm going to use is the endpoints of that segment. Remember, we need 2 points to find the middle or the midpoint, okay? And so down here, that's the origin, so that's 0, 0. Make sure you add that in if you didn't know. That's 0, 0. And so I'm going to use my x values and my coordinates. That would be 2a plus 0. You always divide by 2. Now let's do the y values. Y values, 2b and 0. So 2b plus 0 over 2. Let's simplify. Adding 0 does nothing. So that would be 2a over 2 and 2b over 2. And don't forget your comma. Don't forget your parentheses. Don't forget to have good enough handwriting to make that look like a 2, Mr. Boyden. Okay, and then the way we can simplify these, you got a 2 on top and a 2 on bottom, so we can cancel those out. And so this says a comma b now. And I know that may not look satisfying on this first one because it has letters in it, but that absolutely is the coordinates of point T. Now let's go to W. Okay, on W, we're going to use this segment up here, and we're going to use the x values on the end. So my x values, 2a and 2c. So 2a plus 2c over 2. And I'm going to use my y values, 2b and 2d. We always put them over 2. And so now we're going to try to simplify. And folks, this gets a little bit confusing for people. So I'm going to give you a logical reason why it works this way, and I'm going to give you an algebraic reason as well. Okay, first the logical. You see how a and c are both being doubled? They're being doubled, and then they're divided by 2. If you double something and then cut it in half, you end up with what you have. And so that's one reason why W is going to end up being a plus c, comma, b plus d. Now, some of you are really algebraically inclined. If that didn't make sense to you, try this. You can factor a 2 out of the numerator. So that'd be 2 times a plus c over 2, comma, 2 times b plus d over 2. Now, that could be confusing at first, potentially. What's going on is just think, if you distributed 2 to the a and c, that'd be 2a plus 2c. So it matches what we had before. Then we can see the 2's cancel out, so a plus c is what's left over. So that's the coordinates of W right there. Okay, now with that in mind, let's continue. I'm just going around clockwise around our shape here. So let's go to V and use the x values, 2c plus 2e over 2. And 2d plus 0 over 2. So one thing I hope you'll see is the first ones were kind of confusing and they were different. This one relies on algebra from those first 2 steps. And so now we can see, oh, it's doubled and it's divided by 2, so that those are going to cancel. So that's c plus e for our x value. And then adding 0 does nothing. The 2's cancel out, so that's c comma e, or c plus e, comma d. All right, and we have one more to go. So let's find u. Okay, and again, this is a really good time. If you want to pause the video and try it yourself, this would be a really good chance to try that. Okay, x values, we get 0 plus 2e over 2, and we get 0 plus 0 over 2. Okay, that's cool. That's going to work out just fine. Okay, adding 0 does nothing. 2's cancel out, so we get e. 0 plus 0 is 0, so that's 0. And we have e comma 0 as our last set of coordinates. Okay, so that's the midpoints. Now that we have our points, the students want to know what shape that is in the middle. And so let's consider what it might be. It might be a rectangle. And what would we then know? We would know it had 4 right angles. Or maybe it is a rhombus. And then we would know it had 4 congruent sides. Or maybe it's a parallelogram. And then we would know it had 2 pairs of parallel sides. And so those are things that we think maybe it could be. It could be a square. A square would have all of those properties. And so what we can start to do now is we can use our coordinates and try to test these things. So rectangles right now, with what we know, is going to be really hard to test to see if those are 90-degree angles. However, a rhombus, how to test if there's 4 congruent sides, this actually should be pretty easy because congruent sides mean same length. So that's going to mean we need a distance. If we knew the distance, that would do it. And for parallel sides, that's going to be easy too because all we need to know is the slope. So let's start with this first. I want to test whether or not this is a parallelogram by finding whether or not there's 2 pairs of parallel sides. One reason I like this, if the shape is not a parallelogram, I can immediately also say it's not a rectangle and a rhombus. So that's one reason why it's useful to test parallelogram first. Okay, so let's begin. If we're going to do that, we need to test out the side. So I'm going to start out with side TW, and I want to find the slope. So I'm going to be looking at these two sets of coordinates right here. Now remember, for a slope on top, is it the y values or the x values? Definitely the y values. So here's what I'm going to do. I'm going to do b plus d minus b, and on bottom, I'm going to take the x values, a plus c minus a. Now here's how it simplifies, y'all. If you have b and a minus b, those cancel out. And so what's left over in the numerator is just d. If you have a plus c and you subtract a, the a's cancel out, and all you have left is c. So that's the slope of TW. Now let's go to the segment that we think might be parallel to TW. Looks like UV might be. So let's see. Okay, so same thing. I'm going to do my slope formula, and now I'm looking down here. And so it looks like I could do c plus e minus e for my x values, c plus e minus e, and for my y values, d minus 0. Now d minus 0 is easy to simplify. So I'm going to just put d. C plus e minus e, when you have something minus itself, that cancels. So I have c left over. And look, these two have the same thing. So what does that indicate? Same slope. That means these are parallel lines. So I'm going to make little marks up here. Parallel, parallel. Okay, those are parallel. Awesome. But a parallelogram needs two pairs of parallel sides. So let's now test that and see. So let's find WV's slope. Okay, from W to V, I have, looks like on top, looks like I have B plus D minus D. And that's going to be easy to simplify. And then on the bottom, we have A plus C minus, and you need parentheses here, people, C plus E. Parentheses, okay? So let's do some simplifying. I have a D minus D, that goes away, and B is left over. Over here, I have C minus C, so that goes away. And now I have A, but be careful, y'all. That's minus E, because it's in parentheses, it's being subtracted. So that's A minus E. Okay, so that's VW. It seems like TU, so if that's VW, TU could be parallel. Let's test that. So TU, here it comes. Y values first. And what I get is B minus 0. And then down here I get A minus E. And hey, look at that. B minus 0 is B. A minus E is, it's just A minus E. So these match. So we have another pair of parallel lines. So what can I say based on all this work? I can say that T, W, V, U, that shape, is a parallelogram. Okay, now is it a rhombus? Is it a rectangle? I don't know yet. Okay, we're going to have to figure that out still. We're not done yet. So I'm going to put a little check right here. It's a parallelogram, excuse me, because we showed that there were two pairs of parallel sides using the slope. Now we need to consider using a distance formula to see if this is a rhombus or not. Okay, and that's what we're going to do next. So I'm going to come down here just a little bit. I'm going to show it so I still have my coordinates. And what we're going to do, I'm going to kind of box off my work a little bit. And then I'm going to say distance. So the first one I'm going to do, I'm actually going to do them in the same order as before. I'm going to do TW first. And so for distance, it's going to be very, very similar. Okay, I'm going to take my x values first. I'm going to do A plus C minus A. Remember, it gets squared. Plus B plus D minus B. Okay, a lot of stuff cancels out when we do that. Plus, excuse me. Okay, I got a B and a minus B that cancels out, an A and a minus A that cancels out. And so what I get now is square root of C squared plus D squared. And folks, I'm going to stop there for a minute because I'm not really sure what to do with it. Okay, algebraically, that's pretty much done. So I'm going to label that as TW, and I have an expression right there for the distance. Now before we said TW might be parallel to VU. So all right, so for VU, it's going to be all the same stuff. And y'all, once we've done it once, it should start to feel a little bit easier. For VU now, what we're going to do is we're going to take C plus E minus E, taking our x values. Don't forget to square them. We're going to put a little addition. Now we're going to do our y values. So it looks like d minus 0. And let's simplify. Oop, don't forget to square it. Okay, and I have an e minus e by, so I have c squared left over. And minus 0 does nothing, so I have plus d squared. And look, those match. So what does that tell me? That tells me TW is congruent to VU. Cool. All right, so we have a pair of congruent sides. Let's see if the other sides are congruent to these ones. Okay, we'll do them in the same order as before. We'll do VW next, or WV. Okay, and WV. And so I can do B plus, or excuse me, we'll do the X values first, just like before. So A plus C minus C plus E squared plus, now we need to do the Y values, B plus D minus D. Okay, now for a lot of people, including myself when I was learning this, this gets rather overwhelming. And so one of the things I'd want you to notice is that this little chunk of algebra right here is the exact same thing that we've already done. Okay, we've done this before, and since we've already done it, we already know what the result is. We already know this simplifies out to a minus e. So rather than me going through all the steps again, I'm going to rely on the work I've already done. Since we know that simplifies to a minus e, I'm just going to write a minus e. It's still squared. We've already simplified this. D and D cancel out, and so I get plus b squared. And I don't really know what to do with that, so I'm going to pause. And we have one more to go. And it looks like that is TU. And folks, something very similar is going to happen on TU right here. So for TU, looks like I have a minus e squared. That's the x values squared. Let's go to the y values. I'll make that look like an e. Apologize. And then we'll go to the y values, and it looks like b minus 0. And so when that simplifies, I still have a minus e squared plus b squared, and there's still a square root. And folks, look, those match. How cool is that? And so that tells us that WV is congruent to TU. Awesome. So we have the opposite sides are congruent. Now the only trick is, are these all four of them congruent? I'm not really sure right now. It's based on what I see here, it's not particularly clear. But so this lines up with what we already knew. Okay, we already knew we had a parallelogram. And now we have more evidence that we have a parallelogram, but since not all of them are the same, I cannot say that this is a rhombus. And actually, I misspoke a minute ago, I can't say that it's a rectangle either because we haven't checked to see if it's right angles. Based on the skills we've learned, this is all we can say for right now, and we'll address that question in a later video. Okay, a couple more things, fairly quick, and then we're going to be done for the day. Okay, and here it is. Okay, here we've got an example, and we're playing again with these coordinates in general. And so with this one, the rectangle centered at the origin. Awesome, there's the origin, and we want to give the coordinates of the 4 points. So folks, here's all it is. L is right here, and we're going down to there. To get from L to M, did we go up, down, left, or right? I hope you can see we went down. Going up and down changes the y value. Okay, and the y value here is b. So a stays the same. So the coordinates of M, it's still a. And what about b? For b, it's not up here anymore. It flipped over the axis. It's a reflection. So that's actually negative b. Now to get from here over to n, same thing, except we're moving left. So now the x value is going to change. So that's negative a, negative b. The other thing you could notice about that, if those are both negative, that means go to the left and go down. From the origin, we go left and down to get there. And then up here, now we just move to the left from here, so we're still above the y-axis, so our y value is still positive, but our x value now is negative. And that's the coordinates of the points, y'all. Okay, let's do one more. Okay, here's the next one. We need to give the coordinates in the parallelogram. You may want to pause the video so you can draw this, okay? Okay, and there's just a little bit of a trick. One thing that I'd like to help you see is that there's a little triangle right here. Okay, and they didn't draw it in, but I'm drawing it in for you. Okay, and do you know how tall that triangle is? What the y value is that describes it? Okay, it goes all the way up to c, so that height is c, and this distance right here is b. That's the x, that's the left and right. Okay, because really what we're trying to do to get the coordinates of this point. We're trying to say how high above the x-axis is the point. That's the y value. And we're trying to say how far to the right is it, except I drew too far. So it's not that far. Excuse me on that. How far to the right is it from the y-axis? Okay, so we draw those in. This is how I like to do it at least. Okay, this is going to be my x value. And so I know that's b. From here to here is from 0 to s. So that's s. And then do we know how far it is from here to there? Well, the one way we can see that is if I draw in this triangle. You see how this triangle over here and that one are congruent? So guess what? That means they have the same side lengths. Okay, so that's c and that's b. So this length is b. If that's s and that's b, how long is the whole length? That's s plus b. And the height of this point Q, notice, it's the same height as C, or as point R, so that's also C. So folks, there's your answer on that. Okay, now I'm going to give you one more shot if you want to try one on your own. Okay, try this one. Pause the video now because I'm about to write out the coordinates of point B for you. All right, folks. There it is. I think that's enough for today. This has been a pretty lengthy video and one that for a lot of new students can at times be sort of challenging. So that'll be enough for now. I hope you enjoyed it and we'll see you next time.